we start our lesson now. So ladies and gentlemen, good morning, and welcome back to Mr. Lee Physics class. So today we'll learn about the projectile motion. Ladies and gentlemen, projectile motion, we have two types of projectile motion. We learn the first type of the projectile motion, okay, where that is the, okay, we project an object, okay, horizontal projection. This means that, let's say we stand at the top of a building. At the top of the building, we project an object. We throw out an object. The motion we throw horizontally out like this object. So when we throw out, okay, sorry. So when let's say when an object, okay, is falling down, okay, so the displacement will increase first. Okay, so from here, if the object, okay, if falling down, let's say we notice that, let's say falling first, yeah. So the object is falling down. How is the acceleration? We notice that the acceleration are always constant. Okay, the acceleration are always constant, where the velocity keep on increase. Okay, increase constantly, and there will be the force. The force act on the object always constant. Okay, so if another object, okay, let's say if there is 2 kg, so that means that the magnitude of force increase, the velocity actually are equal. Acceleration, both of them are equal. Okay, so if we look at the path move like that. Okay, so the track and path together. This is for the, okay, graph of the displacement. If the displacement is a curve, that means that for a velocity it will be a straight line. If there is a straight line, that means that there will be a constant acceleration. Okay, so next we move to the sorry, I shared the screen just now, right? Okay, so let's see the next. Now we notice that just now is an object falling down. Okay, if object drop only, that means that it will be going down like that, right? If we launch an object, that means that we notice that this object, okay, we launch the object, yeah. I launch the object, that means that we notice that it will falling down like that. So when we look at the, okay, the track of falling down will be like that. Okay, the path of the path is like that, right? So I show the path and the track together. The force are always same with just now, actually. Same with the drop. Okay, so we notice that how is the force? The force for both of them, actually for the force going down are equal downwards. Velocity, this one just have the downwards velocity. But here, there will be horizontal and vertical, okay, horizontal and vertical force. So the velocity. And there will be a resultant velocity. Okay, how about the acceleration? Acceleration for them are always going down. Okay, so compare, okay, the time, okay, the time falling down actually same with the, okay, object falling, okay, straight. So from here, okay, we notice that the resultant velocity keep on increase. The vertical velocity, okay, there will be a negative value, negative velocity, but constant. Here will be the horizontal velocity. So this means that when the object project in this motion, we get that the horizontal velocity are always constant. Okay. If the acceleration always 9.81 ms negative 2. Now, let me see here. Okay. Let's solve some question first before we go through the further of the projectile motion. Okay, so here class, sketch a velocity. So student, you got this question where I gave you before. Soalan ni ada tak? Okay, now we look at here. Sketch a velocity time graph to show how the velocity of a falling object change as it falls. Okay, and how could you find its acceleration from the graph? So this means that sketch a velocity time graph. That means that we need, okay, this is the question number 1. So we will, okay, we need to draw a velocity time graph. Okay, this velocity, this will be the, okay, where's my pen? Review. The question is, sketch a velocity time to show how the velocity of a falling object change. When an object is falling, that means that its velocity increase. When the object is falling down, that means that the speed is increased constantly. So how to get the acceleration? Is equal to the gradient of VT graph. Okay, that means this is the question number 1. Question number 2. Question number 2, a stone is dropped into a crater on the moon. After 2 seconds, it is moving at 3.2 ms negative 1. And what is the value of the acceleration due to the gravity of the moon on the moon? And how far does the stone fall during 2 seconds? Okay, in 2 seconds, it's moved for 3.2 ms negative 1. Okay, so from here, what we want to find? We want to find the acceleration. We want to find the distance. In this situation, we use the graph motion. It's more easier to us to solve it. Okay, for question number 2, same thing. We draw the the x and y axis. Okay, so let's say this is velocity. That means v slash ms -1 time taken t second. And this okay, so that means that the question told us in 2 seconds, this object moved for 3.2 ms -1, right? Okay, so from here, what we want to find? Acceleration. If find the acceleration A, that means that it will be the gradient, right? So that means that this will be 3.2. Okay, so that means that, and with the origin 0.0, the coordinate, that means that it will be 3.2 minus 0 over 2 minus 0. Okay, so that means that 3.2, that's 1.6 ms -2. If we wish to find the displacement, that means that find the area under the graph. So it will be triangle 1.2 dash 2 times with the height 3.2. So I get that this one cancel. That means that at the end is 3.2 meter only. Okay, next. Okay, throwing up. So sketch a velocity time graph to represent a stone being thrown upwards with an initial velocity of 15 ms -1. 1. Calculate the time at which the stone reached the highest point and when it's returned to the ground. And second, maximum height attained. Ladies and gentlemen, this type of question will be the basic. This will be the most basic for the projectile motion. Question number 3. Okay, let's solve the question number 3 now. Okay, just now given that question number 3. Question number 3, they said that when an object is, okay, sketch a velocity time graph again. Okay, a velocity time graph. Okay, let me copy. When the question is, we throw upward, the object throw upward with a velocity of 15 ms -1. That means that initial will be 15 ms -1, but the object, when throw upwards, the speed will reduce and reduce. Okay, the speed is reduced. That means that this will be the velocity and the time taken. Okay, when it reached the maximum point, that means when object is thrown upward, once it will move up until it reach to the maximum, that means that hash maximum. So that means that the time taken is t. Okay. After that, it will falling down. Correct or not? If move up with t, that means falling down with the same time taken. So that means that calculate the time t time. That means that when it reach to the ground, that means that it will use the same, okay, another distance, okay, until it reach to a point of 2t. So that means that initially is 15 ms negative 1. So what is the time taken? So once we want to find the time taken, okay, as we know that what is the acceleration? Acceleration due to gravity is 9.81 ms negative 1, right? That will be the gradient, right? So from here, 15, the coordinate, that means that will be 0, 15. And this will be t0, right? By using the gradient, 9.81 is equal to 15 minus 0 over 0 minus t. So that means from here, t, we get that t is equal to 1.53 seconds. The time taken is 1.53. That means to reach the maximum height. When the time taken, okay, time, okay, to fall back, that means that it will be equal to 2t. So that means that it will be 2 times 1.53. So that means that total time taken is 3.06 seconds. And the maximum height, that means that the object maximum height, that means find the object area of this triangle. This will be positive, this will be negative. If we find both, it will become 0. So we just find, okay, one part only. That means that the displacement will be equal to 1 over 2. Base will be t, 3.06 times with the height is 15. So total, we get finally, we get the time taken is equal to how much? Sorry, the time taken is 1.53 to reach the maximum height. 1.53. So here we get that it will be 11.5 meter. Okay, Kong Young, SPM level. Okay, actually the old syllabus SPM we just use 10 ms negative 2. You are the last batch. Okay, you all are the last batch before KSSM. KSSM. Okay, so the new syllabus actually your junior adik awak. Okay, all of them already use G equal to 9.81 ms negative 2. In nowadays, SPM already use 9.81 ms negative 2. Okay, so that means no more use 10 ms negative 2. Okay, for the acceleration, except the question asks you to use 10. Okay, now, okay, next question. Okay, question number 4. Sketch a velocity time graph for an object thrown vertically upwards from the ground with initial velocity 20 ms negative 1. What are the times after the projection? The object is at the height of 10 meters. Okay, so that means that, okay, in this concept, that means that, okay, yeah. This is the velocity v slash ms negative 1, and this will be the t second time. And initially, we throw the object with 20 ms negative 1. What? Later, yeah. Okay, so from here, they said that what are the time after the projection? The object is at the height of 10 meter. That means that from the VT graph, if we want to find the displacement, that means we find the area, right? So that means that area maximum, is it maximum? No. Okay, so we want to find the time at here. What will be the velocity Vt if the area equal to 10 meter? That means S equal to 10 meter. Okay, so from here we use the formula. S is equal to 1 over 2. This is a trapezium, right? Okay, that means that 20 plus with the V, plus with the V times with the T. So this will be the equation 1. Okay, so this means that from here I can set that we concluded ten equal to 1 over 2 20 plus V times T. So that means that, okay, this is the equation 1. Equation 2, what we have. So from here, that means that 20 minus V, 20 minus V over the T, what will be the gradient? The gradient, that means show that the acceleration, right? Okay, the acceleration equal to 9.81 ms negative 2. Okay, so from here, this will be because the, what is that? The gradient is negative, right? So no matter how, okay, we use the formula 20 minus t over the time, we get that it will be equal to negative 9.81. So this will be the question number 2. By substitute, solve it by, okay, substitute, let me see. So from here, this will be equal to what? So this means that if I use, let me check a while, yeah. S equal to 1 over 2, 20 Vt. That will be the displacement. So by using the, if I use the T, what are the time? We meant the T, that means V. From here, V is equal to okay 9.81 T. Okay, so 20 minus, okay, so that means that I will get that this will be 20 minus 9.81 T. So V is equal to 20 minus 9.81 T. Let's say this is the question number 2. Substitute the equation 2 into equation 1. So that means we get that 10 equal to 1/2 20 plus V. That means 20 minus 9.81 T times with the T. So we'll get that 9.81 T squared minus 40T plus 20 equal to 0. That means that we'll get 2 times. Okay, solving the quadratic equation, the T is equal to 0. T is equal to what happened? The T equal to 0.5 at second and T equal to 3.5 second. That means that this will be 0.5 second because the object we throw upward, right? Okay, we throw upward when it reach, let's say this is 0 meter, when it reach to 10 meter. That means that when go up, the first 10 meter will be 0.5 at second, 0.5 at second. When it moves to the maximum height, it will fall down again. The next time will be 3.5 seconds, where it reached the 10 meter height. So that means that this is what is the method we use to find it. So now, okay, what are the times after the projection? That means 2 times, 0.5 at and 3.5 second. So print screen ya, kalau tak sempat dia akan putus ya, nanti tak dapat lagi ya. Okay, get it? Okay, so now we move to the projectile motion. Okay, ladies and gentlemen, let me check the, okay, I on the, let's go to the next